Hello. हेलो, राहुल आवाज आ रही है? राहुल कुमार, हेलो। हेलो, राहुल आवाज आ रही है कि नहीं?
Yes, sir.
Yes, sir.
Okay. Just wait 1 minute and then we will start to the class. Okay. Okay, fine. So let's we start today class. Okay, some students are in meeting room, so just allow him and then continue. So today we are going to determine the equivalent circuit of the three-phase induction motor. Okay. So for the equivalent circuit parameter of the three-phase induction, which types of test we will perform, so we can find out the equivalent circuit parameter. Okay. So I will know that just similar to the no load test and short circuit test, you already perform in the transformer. Okay. So how we can find the equivalent circuit parameter of three-phase induction motor? Anyone? Which type of test we require to perform on the three-phase induction motor, so we are able to find out the equivalent circuit parameter of the three-phase induction motor?
V by F parameter, sir. Test, sorry. Voltage by frequency.
V by F.
हाँ.
V by F कौन सा टेस्ट करने से क्या मिलेगा हम लोग?
नहीं, हम कहीं पढ़े थे, वो यूज होता है निकालने के लिए.
कौन सा मशीन के लिए ये?
थ्री फेज इंडक्शन मोटर. थ्री फेज इंडक्शन मशीन.
थ्री-फेज इंडक्शन मशीन. Okay, so we are talking here about the three-phase induction motor. Okay. So for the three-phase induction motor, if you want to find the equivalent circuit parameter, I think, are you familiar with the equivalent circuit parameter of the three-phase induction motor? I hope that. All of you familiar na with the equivalent circuit of the three-phase induction motor?
नो सर अभी पढ़े नहीं है।
अभी नहीं स्टार्ट हुआ है क्या इंडक्शन मोटर?
नो सर।
ओके, क्या सिंक्रोनस में से चल रहा है क्या?
सर आज तो टॉर्क पर आए हैं।
टॉर्क पढ़ाए थे, टॉर्क का इक्वेशन क्या है इंडक्शन मोटर के लिए?
नहीं सर अभी तो सिंक्रोनस भी स्टार्ट नहीं हुआ सर, थोड़ा सा पीछे चल रहे हैं 500।
सिंक्रोनस मशीन स्टार्ट किया ना, हो सकता है जो सिंक्रोनस मशीन स्टार्ट किया होगा अभी।
ये सर मतलब स्टार्टिंग ही है, ईएमएफ थोड़ा बताए थे तो आज ही तो टॉर्क ही स्टार्ट किया।
ओके, तो मतलब स्टार्ट हुआ, इंडक्शन मोटर स्टार्ट हुआ है ना आज?
यस सर।
ओके,
नो सर इंडक्शन का सिंक्रोनस तो स्टार्ट ही नहीं हुआ अभी तक।
सिंक्रोनस मशीन ना?
सिंक्रोनस में ही है शायद, अभी इंडक्शन तो अभी बहुत दूर है।
अच्छा, after synchronous machine completed, then I think we will start induction motor, three-phase induction motor. Okay, so for the equivalent circuit representation, I think okay, maybe this is very similar to the equivalent circuit of the transformer. Okay, have you remember that one? Equivalent circuit for the transformer. Equivalent circuit of the transformer, have you remember?
Yes, sir.
Which type of test we perform on the transformer for find the equivalent circuit parameter?
No load test and full load test.
No load test and full load test,
Full load.
or maybe known as the short circuit test. Okay, full load test is also
Short circuit and open circuit test.
open circuit. Yeah. So I think you are familiar with the transformer. Okay. So just similar to that one, whatever the parameters we represent for the transformer in the two winding, primary and secondary winding, and their equivalent circuit representation, that means either transfer the primary and secondary winding from one side to another side. So I think are you all of you familiar with three-phase induction transformer equivalent circuit parameter? Okay, so similar to that one, you have to just answer about this what we have to perform in the transformer, that means no load test and short circuit test. Why we perform the no load test? So that we can just compare here from the transformer and three-phase induction motor, just very similar to that one. Okay, why we perform the no load test on the transformer?
Sir, to know the resistance or inductance जानने के लिए उसका.
Resistance or inductance? Yeah.
हाँ.
Exactly. Conservation. That means core loss resistance and magnetizing reactance. Right?
हाँ. Yes, sir.
Yes, sir.
L or
Core loss resistance and magnetizing reactance. We just perform the no load test. Okay. And why we perform the short circuit test of the transformer?
Sir, maximum efficiency.
Maximum efficiency. That means you can find out if losses of the transformer. Okay. At the no load total losses, we just also can.
Iron loss.
Yeah, whatever the power consumed during the no load test, that is known as the core loss, is not. And if you perform the short circuit test, then whatever the power consumed during that test, just consider as the ohmic losses. Okay. So when you perform these two tests, so you are able to find the efficiency. Okay. So whatever the input power subtracted from the input power and subtract the losses, then you will get the output power. Okay, so output by the input power is your efficiency. So we can also calculate the efficiency of the transformer, and total equivalent circuit parameter. That means we just a few minutes earlier mentioned that the resistance and leakage reactance, core loss resistance and leakage reactance, okay, can be calculated with the help of no load test. And if we perform the open circuit short circuit test, then we can find the other parameters, resistance of the primary winding and secondary winding, referred to either side, that means high voltage side and low voltage side. So that leakage resistance and reactance value can be find with the help of short circuit test of the transformer. Okay. So similar to that one, just we consider here again no load test and short circuit test. You can say that the short circuit test or block rotor test. That means at rated current, we perform the block rotor test. Okay, since the rotor winding here rotating one, so we just block by the external or by pulley arrangement, with the help of pulley arrangement. Okay, so if we perform these two tests on the three-phase induction motor, similarly we can find equivalent circuit parameter of the three-phase induction motor. Okay. That means with the help of no load test, we can find just X no load, that means reactance, or magnetizing reactance at the no load condition. Okay, so just see the screen. Okay. So one is no load test and another is your block rotor test. Okay. So with the help of no load test, we can perform the find the parameters magnetizing reactance at the no load. Okay. So I think you are familiar with the circuit diagram. That means rotor total equivalent resistance of the rotor circuit. Okay. Rotor. So just what we find out here, that what is the objective of this experiment, that is block rotor test. You can just find out the parameters of the rotor circuit. That means X VR and block rotor leakage reactance, that is nothing but the X1 plus Xm by X2. Okay. So objective of this experiment, block rotor test, this test is performed to determine the short circuit current, I short circuit, with normal applied voltage to a stator, power factor on short circuit, and total equivalent resistance. That means rotor resistance. Okay, total equivalent resistance, rotor as well as the stator resistance. Okay, so total equivalent resistance and reactance of the motor as referred to a stator. Okay, just similar to the transformer. That means secondary side parameters transfer towards the primary side, is not. And no load test performed on the low voltage side and high voltage side is kept open, is not. So similarly, here all the parameters we can find out. That means total equivalent resistance and reactance. Total resistance, that means which one? Stator resistance, इसमें मोटर के लिए क्या आएगा? Stator resistance and rotor resistance refer to the stator side, and total reactance, that means stator reactance and rotor reactance refer to the stator side. तो पैरामीटर्स हम लोग कैसे ट्रांसफर करते हैं वन साइड टू अनदर साइड, तुम लोग आई थिंक फेमिलियर होगा उससे.
हाँ सर, रेशियो से, वो टर्न्स का रेशियो से, n1 बाय n2
टर्न्स का रेशियो से. ओके, तो रेजिस्टेंस हम लोग कैसे ट्रांसफर करते हैं? यदि सेकेंडरी साइड का प्राइमरी साइड लेके जाना है तो जस्ट टर्न्स का रेशियो का स्क्वायर होता है एक्चुअली. दैट मींस स्क्वायर ऑफ द टर्न्स रेशियो. दैट मींस यदि हम लोग प्राइमरी साइड लेके जाना चाह रहे हैं तो क्या हो जाएगा? n1 by n2 का होल स्क्वायर है. and R2 यदि secondary side resistance है, तो if we want to transfer the secondary side resistance towards the primary side, then we can just write the equivalent value of the R2 and refer to the primary side. That means R2 into N1 by N2 whole square. नहीं, ट्रांसफर करने के लिए तो ध्यान में यही कैसे हम लोग ट्रांसफर करते हैं, रेजिस्टेंस, रिएक्टेंस एंड वोल्टेज कैसे ट्रांसफर करते हैं, करंट पैरामीटर्स कैसे ट्रांसफर करते हैं। यदि सेकेंडरी
सर
साइड
वो
में
सिर्फ स्क्वायर नहीं होता है, N1 by N2 equal to
N1
M
by
by
N2 हो जाएगा वोल्टेज के लिए, नहीं EMF induced equation you already know that the direct proportional to the number of turns, so that means V1 V2 is directly proportional to the N1 by N2 and current ट्रांसफर करते हैं रिवर्स हो जाएगा, that means N2 by N1, नहीं। So you have to concern about the transfer of the resistance and reactance of the induction motor from rotor, यहाँ पे secondary side के लिए क्या आ जाएगा, rotor instead of secondary winding of the transformer, okay। So the secondary winding, that means the rotor resistance and reactance, if you transfer towards the stator side, okay। यहाँ तक रेजिस्टेंस रिएक्टेंस ट्रांसफर करने में कोई दिक्कत नहीं है, ओके। सो यू हैव टू जस्ट
इसमें भी सेम ही होगा सर जैसे उसमें था ट्रांसफार्मर में।
हाँ, जस्ट क्या है यहाँ पे रोटर रेजिस्टेंस का पैरामीटर R2 रेजिस्टेंस रिप्रेजेंट करेंगे R2 से, रिएक्टेंस रिप्रेजेंट करेंगे X2 से, ठीक है। इसको ट्रांसफर करना है हम लोग,
वहाँ तो प्राइमरी सेकेंडरी में करते थे,
वहाँ पे प्राइमरी और सेकेंडरी बोलते हैं, यहाँ पे वही चीज कॉइल जिससे प्लेस किया हुआ उस अनुसार से सिर्फ नाम दिया हुआ। यहाँ पे हम लोग प्राइमरी जो वन कॉइल जो प्लेस किया है स्टेटर में, अनदर कॉइल इज प्लेस्ड ऑन दी रोटर, ओके। टू कॉइल आल्सो,
अच्छा स्टेटर से रोटर में,
stator and rotor placement. If you study the construction of the three-phase induction motor, then you will find the placement of the one winding on the stator and another winding on the rotor, similar to the transformer, one winding on the primary side and another winding on the secondary side, okay। Due to the mutual induction, again here energy is transferred from one coil to another coil, okay। So the equivalent circuit is almost similar to the same, that means the block rotor test is similar to the short circuit test of the transformer, okay। Since we just short circuit of the transformer perform, so here we can also perform on the block rotor test of the three-phase induction motor, okay। ये actually rotor part is moving part, okay। So if you want to short circuit, that means you have to require block this rotor movement, okay, by the with the help of some external force or maybe pulley arrangement and belt. So you can just stop the movement of the rotor, okay। That is known as the short circuit test, just similar to the induction motor, transformer, okay। So these are the objective we can find out, that means the short circuit current with the normal applied voltage to the stator, power factor on the short circuit, total equivalent resistance and reactance referred to the motor. So the rotor lock rotor test is done by the mechanically holding the motor shaft from the turning and apply a reduced voltage on the stator, okay। So another overview, that means blocking the rotor from rotating is equivalent to make I think you may be not familiar with this term sleep, okay। So sleep, have you heard the name of sleep? What is the sleep?
स्लिप होता है सर कि वो जो सिंक्रोनस होता है स्टेटर, मतलब कि मैकेनिकल, एक होता है मैकेनिकल डिग्री, का होता है इलेक्ट्रिकल डिग्री, तो दोनों के बीच का जो डिफरेंस होता है दोनों की स्पीड में, उसको स्लिप बोलते हैं।
एक मिनट जस्ट Okay, so क्या बताया था? Just sleep, just some called to the truth.
स्लिप उसको बोलते हैं जो NS माइनस NR, मतलब कि डिफरेंस दोनों का स्पीड का, एक जो इलेक्ट्रिकल मूव कर रहा है और एक जो मैकेनिकल मतलब रोटर मूव कर रहा है, तो
Okay,
दोनों के बीच का डिफरेंस, दोनों के बीच का स्पीड का डिफरेंस,
okay,
उसको बोलते हैं स्लिप।
sleep.
Am I right ना सर?
Some part is right. You are not completed. That is the definition of sleep. Okay, that difference, whatever you saying that NS minus NR, that difference is divided by the synchronous speed of the machine. Okay, that is known as sleep. NS minus NR divided by NS. Okay, is it clear?
Yes sir, clear.
NS minus NR divided by NS. You know that NS and NR is the synchronous speed of the magnetic field, whatever they produced in the stator part, and NR is your synchronous speed rotating of the rotor. Okay, with respect to the NS. So that is known as sleep. Okay, so if the rotor movement we block complete or stop completely, then NR equal to how much? 0? Is it not? NR equal to
Yes sir.
0.
0.
So what is the sleep at the block rotor test? That means 1 NS S equal to NS minus NR divided by NS. Okay. So at the block rotor test, the sleep makes the 1. Okay. And this is your rotor, that means R2 dash, if you transfer, that means so 1 by 1 minus S, okay, transfer from one side, equal to rotor resistance equal to how much? 0 if you put the sleep equal to 1. Okay, if you put sleep equal to 1, then you will get the resistance value at this 0. So at the block rotor test, the S is sleep is 1. Just one student on the waiting, so just allow him. So this test is conducted by applying a low voltage to the stator winding, so that to limit the current drawn to its full load value. Since we are not apply any load on the rotor side, so just whatever we just perform a short circuit test, na? So we just apply low voltage that is required for the rated current flow in the rotor winding. Okay, so rated current may flow at the 2 to 12% is more than up to 30%, 30% of the rated voltage. Okay, so 30% of the rated voltage is required for the rated current flow in the rotor conductor. Okay, so at this reduced voltage, the core losses can be neglected. We are not. You maybe know that the core loss can be assumed on the no load test. Okay, and in this test, block rotor test, just consider the ohmic loss. That means I square R loss. Okay, so but the effect of XM has to be taken into account. So you may be familiar with this circuit. Okay, so list of symbol you may find out here. That means F suffix BL that represented the rated electrical frequency of the motor. V1 BL, okay, V suffix 1 BL, that means the line to neutral voltage, phase voltage applied to the motor, okay, line to neutral voltage, okay, and I1 BL is the line current, and PBL the polyphase electrical input power, okay, and SBL that means total apparent power of the rotor, whatever the power during the block rotor test required. Okay. Apparent power का rating क्या होता है? What is the apparent power? That means can be represented here apparent power, that is SBL. So what is the apparent power rating? We can represent the apparent power rating. And
Sir,
Q,
KVA.
KVA, exactly. Okay.
Yes.
KVA. And this will qualify electrical input power. The P represent your active power. So unit of active power here. What is the unit of
Sir, what, sir? What, sir?
watt? Kilowatt. If you rated power represent in KVA, that means this one is in kilowatt. Okay. So kilowatt it will be. And since all the power represented in the same unit, okay, that means either you represent in kilo or mega, whatever you may want. If MVA represented, sorry, apparent power represented by the kilovolt ampere, then the active power you represent in the also in the kilowatt, okay. And this one block rotor reactive power, what is the unit of reactive power? What is the unit of reactive power?
kVAR, sir.
Yeah, so kilovar, okay, is the unit of the reactive power, and XBL is your block rotor reactance, okay. That means rotor reactance, whatever the transfer stator to resistance towards the rotor side, okay. So XBR we may be consider as the block rotor reactance, okay. So, and what is the block rotor resistance? Can be represented by block rotor resistance can be represented by this one. रेजिस्टेंस रिप्रेजेंटेड यहाँ पे दिखाया नहीं है ना, क्योंकि रिएक्टेंस हो गया, इंपीडेंस हो गया, तो व्हाट इज द रेजिस्टेंस? रेजिस्टेंस ब्लॉक रोटर रेजिस्टेंस कैन बी रिप्रेजेंट RBR.
RBR.
Yeah, RBR. Okay. So if you perform this test, rotor test, then you require this parameter calculation. That means XBR. Okay, block rotor reactance XBR and RBR. Okay, rotor block rotor resistance RBR and XBR. Okay. So how we can perform this test? So this parameter we can calculate with the help of block rotor test. Okay, block rotor resistance and block rotor reactance, that means XBR. Okay, so whatever the instrument we require to connect the this various reading, whatever the power consumed during the block rotor test and current flow during the block rotor test and voltage. Okay, so if 1 wattmeter connected during the block rotor test and 1 voltmeter and 1 ammeter for the whatever voltage, current and power consumed during this test. Okay, so just similar to the wattmeter, voltmeter and ammeter required for perform the open circuit and short circuit test for the transformer, all those instruments again required here for perform the 3-phase induction motor block rotor test also. Okay, so that means 1 wattmeter, 1 ammeter, 1 voltmeter you required here. Okay, so whatever the power reading at the block rotor test, okay, that is indicated by the wattmeter and ammeter block rotor current at the block rotor current. So यदि पावर मिल गया हम लोग को, करंट का वैल्यू मिल गया है, तो रेजिस्टेंस का वैल्यू हम लोग निकाल सकते हैं, RBR इक्वल टू निकाल सकते हैं ना, पावर इक्वल टू क्या लिखते हैं, I2R ओमिक लॉस नहीं, पावर इक्वल टू I2R लॉस. So R, that means resistance of the rotor, block rotor. If you want to find out, that means whatever the wattmeter reading that we require to find. Okay. So RBR इक्वल टू कितना लिख सकते हैं, वाट मीटर का जो रीडिंग आएगा, दैट मीन्स पावर ऑफ दिस ब्लॉक रोटर टेस्ट ऑफ द एक्टिव पावर डिवाइडेड बाय करंट ड्रॉन फ्रॉम द सप्लाई, दैट मीन्स IBR। ओके, तो RBR मिल जाएगा। यदि RBR मिल जाएगा तो हम लोग ZBR इक्वल टू कितना लिख सकते हैं, इंपीडेंस इक्वल टू कितना लिख सकते हैं, वोल्टेज बाय करंट। हेलो,
यस सर।
इंपीडेंस इक्वल टू वोल्टेज बाय करंट लिख सकते हैं, तो वहां से ZBR मिल जाएगा हम लोग, इज नॉट, क्योंकि वाट मीटर वोल्ट मीटर एंड एमीटर से हम लोग को वोल्ट मीटर और एमीटर का रीडिंग मिल जाएगा शॉर्ट सर्किट पे, तो हम लोग ZBR निकाल सकते हैं।
सर शॉर्ट सर्किट है तो वोल्टेज 0 होना चाहिए ना।
शॉर्ट सर्किट है तो वोल्टेज जीरो होगा, तो उसको हम लोग जीरो तो कर ही रहे हैं वोल्टेज, तो हम लोग जो रोटर को ब्लॉक कर रहे हैं, ठीक है,
रिएक्टेंस भी 0 हो जाना चाहिए।
एक मिनट जस्ट वेट करो। जैसे हम लोग ब्लॉक रोटर कर रहे हैं, जैसे हम लोग क्या कर रहे हैं, ब्लॉक रोटर टेस्ट कर रहे हैं, दैट मीन्स रेटेड करंट हम लोग फ्लो कराना है, ठीक है। अब जैसे ही रेटेड करंट हम लोग को फ्लो कराना है, और उस कंडीशन में क्या करना है, मूवमेंट ऑफ द रोटर हम लोग स्टॉप कर रहे हैं विद द हेल्प ऑफ बेल्ट एंड पुली अरेंजमेंट। ओके, with the help of belt and pulley arrangement. So at that instant, whatever the voltage required for flow the rated current, that voltage we need to supply na. So some voltage we required to supply given through the help of stator. Okay, is clear?
हाँ यस सर, आगे।
तो वो वोल्टेज डिवाइडेड बाय व्हाट एवर द करंट टेकन फ्रॉम द सप्लाई, दैट करंट एंड वोल्टेज रीडिंग कैन बी टेक विद द हेल्प ऑफ वोल्ट मीटर एंड एमीटर। वोल्टेज का रेटिंग हम लोग चेंज करते रहेंगे एंड एमीटर का रीडिंग हम लोग नोट डाउन करते रहेंगे। एमीटर का रीडिंग यदि रेटेड करंट पे पहुंच जाएगा, उस इंस्टेंट पे हम लोग क्या करेंगे, वोल्टेज का जो वेरिंग पोजीशन है उसको हम लोग मूव करना स्टॉप कर देंगे। ओके, so we concern about the rated current flow through the rotor winding. Okay, तो ZBR मिल जाएगा, RBR मिल गया, तो हम लोग वहां से क्या निकाल सकते हैं, XBR निकाल सकते हैं, तीनों ठीक है कि ना। So this is the equivalent circuit of the three-phase induction motor. We find out just similar to that one. That means this one is your just similar to the transformer. This one is represented for the primary, is not, and this one is for the secondary. But here we say that the secondary coil is placed on the rotor. So when we talking about the three-phase induction motor, so we just concern about the stator winding and rotor winding. Okay, instead of primary and secondary in the transformer. Okay, so have you kept in mind this? So the short circuit test on a transformer, the block rotor test on the induction motor give information with respect to the leakage impedance. Okay, so the rotor is blocked so that it cannot rotate, and the slip is equal to 1, already explained some few minutes earlier. Okay, and balanced polyphase voltage are applied to the stator terminal. Okay, so resistance since R2 into 1 minus S, so slip equal to 1. Okay, so this can be simplified as this one is 0, so R1 plus X1 and R2 plus X2 is similarly. So just find the equivalent resistance, since this resistance and the resistance are connected in series, so you may write here equivalent resistance, and this resistance and X1 and X2 are connected in series, so you may be write here X equivalent. Okay, X equivalent. ये यहाँ पे X1 and sorry R2 and X2 refer to as the primary side. Okay, or a stator side, you can say that a stator side. Okay, so this is the simplified equivalent circuit of the motor, three-phase induction motor. Okay, then you can just draw the phasor diagram. Are you I think familiar with the RL circuit? How can we draw the phasor diagram?
सर फेजर डायग्राम थोड़ा दिखाइए ना सर।
Yeah. So this is the phasor diagram of this equivalent circuit. Okay. So how we can draw the phasor diagram for the RL circuit? Remember that. That means this is first we just try to draw the current along the x-axis, and resistance drop is in phase with the current. Okay. So I1, R2 you will find out in the same phase. Okay. And reactance is 90-degree angle on the phase displacement with the current. Okay, so this voltage drop can be represented at the 90-degree. Okay, so this one is your x1, I1 x1. Okay, and this is your for the circuit I1 x2 resistance, rotor resistance I1, and rotor resistance refer to the primary side, that means x2. Okay, and this one is represented for the reactance voltage drop, that means I1 x1. Okay, so this is the phasor diagram of the circuit, and you may be the resultant voltage is your applied voltage, that means V1. Okay, so it's clear whatever the voltage you apply here, that is your drop across this equivalent resistance and equivalent leakage reactance. Is it clear the phasor diagram of the circuit? और किसी को कोई प्रॉब्लम फेजर डायग्राम में?
सर RT लिखा हुआ है यहाँ पे, I1 RT और I1 XT, I1 X1 लिखा है.
I1 RT, that means this is after equivalent resistance. Okay, just you consider this circuit, and if you consider this circuit, okay, and these are indicated for this circuit, that means simple R1 and R2. Okay, so this one, if you consider equivalent resistance RT, that means R1 and R2. Okay, and this is your just represent x1 and x2, that is equivalent resistance xt. So this is T represent here equivalent resistance.
Yes sir, समझ गए.
Okay, so we can just simply draw the phasor diagram. Okay. So we can note down all the reading of the voltmeter, wattmeter, and this ammeter. Okay, and just calculate the parameters of the three-phase induction motor, that means RBR, XBR, that means a block rotor reactance, and block rotor resistance. Okay, so these are some theory explanation, and this apparent power is represented by the how we can represent the apparent power, that means apparent power is the summation of active and reactive power. Okay, so which one represent the from this phasor diagram, which one is represent the active and reactive power? Okay, this one is your resultant is your apparent power phasor diagram, and this one is your active power. Okay, and this one is your reactive power. Okay, so if you write the power equation, then you can KB equal to V square equal to active power square plus reactive power square. Okay, active power square and reactive power square. Okay, so just we stop here, and the next part, that means no load, how we can find the no load and other parameters, we can just explain in the next class. Okay, so I think I have already sent to you. Hello, are you able to hear me? Hello.
Yes sir.
Okay, so just I have one announcement, that means because I have already shared to you link for the next class, link for the